want to address the second input on this model. Yeah. So I, byte 0, dot 1, bit 1. Byte 0, bit 1. Pretty straightforward, really. Let's say I wanted to, I'm going to address the third input of byte 1.
I1.2.
1.2. Yes. Everybody get that? Instead of saying this is slot 0 in the umbrella world, this would be 0/1. This would be 0/ whatever, 8, 9, 10, 11 in the umbrella world.
So the first one on bit 1 would be bit 1 by 0, 2, 3, 4, 5, 6.
Input by 1, bit 0. Yeah, input by 1, bit 1, so on. Another difference in the addressing, which is not a showstopper. Let's say, for example, that this all of a sudden becomes an output line. And the address starts with the letter Q. And I'm guessing they may have done that because it's sometimes hard to distinguish between a 0 and an O. Just my guess. Don't know.
Output in German does not have a Q. Output in German does not have a Q.
You know some German?
I just looked it up.
Oh, okay.
Yeah.
Another thing with Siemens, do you remember the binary data file and an integer data file? Binary and integer? They're basically just, they're addresses that are in memory, right? They're not physical addresses. So to distinguish that in Siemens, they use the letter M as an address for memory. And if we're going to address something, MW23, memory word byte 23. That's just like, pretty much just like the integer data file, right? It's word, the word data file. Here's the difference too. Memory word, the starting byte address is 23.
What is?
No, that's just a
That's just an
random.
example.
Yep, and you can make it about any number you want. It's pretty flexible for addressing. Probably had to remember a lot of the PLC.
That's only if you have all the bits and the word fulfilled. If your inputs and outputs are not made, you're not going to have the memory word made at all.
Right, and this is just an address, that's all that number is. It's just a byte address. But here's the difference. It's memory word, the starting byte address is 23. How many bytes are in a word?
16.
2 bytes?
2 bytes in a word, right? Yeah. 16 bits are in a word, 8 bits are in a byte. So here's the starting byte address. So actually, technically, it's MW23 and 24. You'll see that once we get into analog. That makes sense? because this is the starting byte address. Really the starting byte address. Something else you want to make a note of. If, let's say this tag had a percent sign in front of it. Oh, I wiped it all out. Percent MW23. You're also going to see another symbol, the hashtag or pound sign.
Depending on what generation you're from.
Point for hand.
Hashtag MW. But the percent sign, that means it's a global tag. It's a PLC tag. What do you think the pound sign? Yeah. It's a local tag.
Social media.
Twitter tag.
Eight AM one day?
Everybody put down, but
It was like a month.
hashtag MW23.
Yes, that's right.
So that's your program, you don't understand.
So we talked about the code blocks. What are they? OB, organizational block,
Function,
function. There's three code blocks, and then data blocks.
DB data block.
Yeah, that's not really a code block. Organizational block, which is an OB, an FC, which is a function, FB, function block. What is OB1 the same as in Allen Bradley? Yeah. The same as in Allen Bradley. Anybody remember?
Cycle.
Program cycle.
Now that's an OB type. OB1 is the main routine, or latitude. FC, or function, is a subroutine. A subroutine, what?
Without memory.
Without memory. An FB, function block, is another subroutine. Subroutine what? With memory. How does a function block store its memory? Stores its memory in something that's called an instance data block. So, a data block. There are two types of data blocks. One is a global data block, and one is an instance data block. blocks do is store data, that's all they do. That's all they do. So let's say we run some calculations in a routine, in a function block. And we wanna buffer those off, the results of the calculations, and we send them to a data block. I know it doesn't, it's all just words right now, it doesn't mean a thing to you yet, but it will. So we have instance data blocks. Which are local. And then we have global data block. What does, since you know it's an instance is a local data block, what's that mean exactly?
They're gonna be common, or you,
Think of local tags and global tags.
specific.
Local, yeah, just for a specific local.
Yeah. Yep, a specific code block, yeah. Can only be used by one, code block. And generally it's gonna be an FD. Global data block. Yeah, can be used anywhere. So the data inside there can be used anywhere. Yeah. OB1, FC, FB. There are several types of organizational blocks. And let's talk about this a little bit. Remember in the Allen Bradley world what a project is made up of? Project. There were three main things a project's made up of. A program, right? Let me go in order here so it doesn't get confusing.
Is that what it's a line?
Task. Right? Programs. Events. You're on the right track. Programs and routines. And you're talking about event, yeah, the types of tasks. What were the types of tasks? Periodic. Event. What else? Continuous. And the reason I'm reviewing this is because this is very similar to the organizational blocks. The OBs, what are they in the book? One's program cycle. Yep, organizational block. So we have a program cycle OB. We have a startup OB, right? OB, OBs. What else? Program cycle, startup OB, interrupt OB. Do you see the similarities here? So, a continuous task, what kind of OB is that? Yeah, program cycle OB. Because we're continuously running the program, we're continuously doing a task. How about the event?
Interrupt.
Yes, interrupt. Periodic, obviously the startup, yeah. So, yes. periodic at the startup. We can, and startup OBs are not required. We can make a startup OB, right? We can say, okay, and here's how it works. As soon as the PLC boots up and starts scanning, that's the first thing that happens, is the startup OB. Maybe we want the program for the PLC to go out and check the status of input, or check the status of alarm or faults or that type of stuff. Then we put that information in the startup OB. And it executes by default. You don't have to say, hey, execute this first. It knows, when you say, we're gonna make a startup OB, that's how it knows how to do it. What's the, Josh, you probably heard of OB 100. It's a startup OB, yeah. It's